And in this lesson, section 5, you don't have to memorize any of the identities. So on the test, you will be given a sheet of just the section 5 identities. All of the ones in section 1 and 4, however, until today, you have to have those memorized. Okay? All right.
It's like full of identities.
Well, yeah, and plus, like, those were the basic ones, and then these are kind of like more specialized, and there's no need to memorize them. Okay, so we're gonna talk about double angles today. We started touching on this a little bit in section 3, but let's talk about double angles today. So suppose you have sine of 30. We all know this is a half, right? Now, if I were to say what is 2 times sine of 30, well, that would just be 2 times a half, and that would just be a 1, right? Now, so that's 2 sine theta, basically. 2 times sine of theta. As opposed to, let's start again with sine of 30. We know that's a half. And now suppose I want to do sine of 2 times 30, right? Do you see where the 2 is this time? It's inside with the angle. That makes it sine of 60, which is root 3 over 2. So it's a completely different angle altogether. That, the second one here, this is sine of 2 theta, and we call this a double angle, right? And what's important with double angles is the following. When our original angle was 30, it was in the first quadrant. Double angle of that, 60, is still in the first quadrant, right? But what if my original angle was 70, right? If I have sine of 70, but then sine of 2 times 70 would be in another angle, in another quadrant completely. With sine, okay, with sine it doesn't matter, but with cosine, it would definitely matter, right? It would go from positive to negative, right? So cosine 70 would be positive, but cosine of 2 theta would now be negative. So there is a, you know, a sign change there. So we need to watch out for that, okay? No, didn't say that. It's just where it is, right? Because if I had sine of 100 positive, sine of 2 theta 200, now it's negative. So depending on where your original angle is, the double angle will change its sign. So just watch out for that. Okay, now for sine of 2 theta, there is this is the identity, and look, it's 2 sine theta cosine theta. Notice this is sine of 2 theta, but the identity is sine of single theta cosine of single theta. So that's it for sine of theta. Now, for cosine of 2 theta, there are 3 possibilities. All of those are equally accurate mathematically. You just use one versus the other depending on like what your needs are and what suits you better. You'll know. And then they're really the same. It's just like, do you see how in the first one it's cosine squared minus sine squared? Cosine squared, that's an identity, right? Sine squared plus, so if you substitute 1 minus sine squared for this, you'll get the other one. If you substitute 1 minus cosine squared for this, you'll get the other one. So that's where they come from. And then tangent is this. Okay, you're realizing tangent, right? Because it's a division by itself, sine over cosine. It's always got like a little bit of a fraction involved. Okay, so here we go. We have sine of theta equals 3 over 4 on the interval 0 to pi over 2. So we don't know what the angle is here. We just know that sine of it is 3 over 4. But we are told it's over the interval 0 to pi over 2, which is the first quadrant. Okay? Now, I need to find sine of 2 theta, cosine of 2 theta, tangent of 2 theta. So use these identities. And if you look at the identities in this box, each of these is like a recipe. The one for sine of 2 theta calls for sine theta, cosine theta. Now, I have sine theta. I don't have cosine theta. For this, I need to use the Pythagorean identities. So use a Pythagorean identity to find cosine theta. So here we go. Sine squared theta plus cosine squared theta is equal to 1. And we're experts now on this because we took the quiz. Sine squared theta is 3 over 4 squared, 9 over 16, plus cosine squared theta is 1. Cosine squared theta is 1 minus 9 over 16. 7 over 16. And then when I take a square root of both sides, cosine theta is plus or minus root 7 over 4. No triangle. This is the chapter on identities. You have to know how to do the identities. All right? Now, because we're in the first quadrant, cosine theta is going to be positive, so that's what we're going to take. So cosine theta is root 7 over 4, right? Let me just save some space. Okay, because it was told that it's from 0 to pi over 2. Okay. Okay, so now I need to find sine of 2 theta, right? Sine of 2 theta is 2 sine theta cosine theta. Sine of theta is given, so this is 2 times 3 over 4 times, I just found cosine theta to be root 7 over 4. And now here, please be careful. You can reduce, but just once, right? So this is sine of 2 theta equal to 3 root 7 over 8. Okay. Okay. So here we go. Okay, now I need to find cosine 2 theta. For cosine 2 theta, I have 3 choices. And you know what? I'm going to use the last one just because. You know why I'm going to use the last one? Because it has sine of theta, and that's what was given to me. So I know there is no mistake, right? There is no error. So let me just use that. Everything will work out perfectly. So cosine 2 theta is 1 minus 2 sine squared theta, 1 minus 2 times 9 over 16, 1 minus 9 over 8. So cosine 2 theta is negative 1 over 8. Okay? And so look, my angle is here. 2 theta, it can still be in the first quadrant, or it could be in the second quadrant. In this case, because I got cosine 2 theta equal to some negative number, that means, like theta was big enough so that 2 theta is in quadrant 2. Okay, now, tangent of 2 theta, you have choices again. One choice is this identity. Another choice, we know tangent is always sine over cosine. So why don't we use that? But if it's tangent of 2 theta, it's sine of 2 theta over cosine of 2 theta, right? These have to be matching, identical. So tangent of 2 theta is equal to sine of 2 theta, which we said was 3 root 7 over 8, and then cosine negative 1 over 8. The 8's cancel, so tangent of 2 theta is negative 3 root 7. And there we go. I just found all three. You could have used the identity, or this. This is definitely like much more straightforward. Okay, questions quickly. Yeah.
So, I mean, but we can do that because we already knew what the
Right.
were. But on the homework, if there's a problem with us, we can't do
If it's just tangent theta, then you could just use that. Like if you haven't found sine of 2 theta, if you haven't found cosine of 2 theta, then this one just calls for tangent theta. So find tangent of regular theta, and then you can just do that. Okay, yeah.
Can you just do the sine for the tangent, you just do sine of the cosine? Do we have to go memorize it with the secant?
Okay. Wait, I don't. What?
Can we do it like? Do we do these like cosine and like secant? Will there be secant 2 theta? Yeah.
I mean, secant 2 theta would just be 1 over cosine 2 theta. Secant 2 theta would just be negative 8 over 1. Okay. Okay, so let's go. Let's solve this equation. So, all right, so a tip. If you have a double angle and a single angle in the same equation, you have to rewrite the double angle using one of the identities above. So, like this one. I have cosine 2 theta and cosine single theta. You can't solve this the way it is. They all have to be either double thetas or they all have to be single thetas. So the best bet is to take this and substitute something from this box above. Now, this is cosine 2 theta, and I have to substitute something in its place. So for this one, right, remember cosine, we had 3 options. Which one would you choose? The first, the second, or the third? For this equation. The second, because that just is the only one that makes sense. So you have, all cosines. So this is going to be 2 cosine squared theta minus 1. And then minus cosine theta is equal to 2. Okay. Bring everything to the same side. So minus 2, and then let's write everything in standard form. So this is 2 cosine squared theta minus cosine theta minus 3 is equal to 0. Okay? Factor 2 cosine theta, cosine theta, and so we're going to get a 3 here and a 1 here, and then minus plus, okay? Okay, so here, 2 cosine theta minus 3 is equal to 0. So all of a sudden, this is like section 3. Cosine theta is equal to 3 over 2. And what do you think? No solution, right? It's okay, yeah, be bold, it's fine, right? So this one, cosine theta plus 1 equal to 0. Cosine theta equals negative 1 pi. Okay, and because it's only over the interval 0 to 2 pi, then this is my only answer. If it was over all of the domains, what would it be? Over all values of x. Pi plus 2 pi n. You really have to be careful for those, because if it says to solve over all values of x and you just give one answer, over all values of x, there are billions of solutions here. Now imagine if there were 2 solutions and you only gave one. You know that's wrong. But if there were billions and you only gave one, that's like a billion times more wrong. So it's not like, oops, my bad. No, it's like a thing, right? Like imagine if this was like like some sort of like rubric to calculate, or to figure out, I don't know, like who gets a stimulus check. You know what I mean? And instead of like 345 million people, one person gets it. Like you just lost your job. You know what I mean? Like it wasn't like, oh, whoops, 2 points off. No, like you legit just lost your job. Like these are big things. Okay? All right. Like things these matter, right? 1 degree off for you, 63 degrees versus like 62 degrees might mean nothing. But if you're flying a plane over 10,000 miles, 1 degree is a difference of like landing in the airport or over like Chicago City. You know what I mean? Big, big things. So, like, and you don't want the air traffic controller or the pilot to be off by even a degree when you're right. So, and then this is where like we learn that meticulousness. Okay, those were double angles. Let's go to half angles, right? Okay, now, so remember how, okay, so we know how to do, trig functions for 45 degrees. We know how to do trig functions for 30 degrees. And then there was a time that we didn't know how to do anything for if you had 15 degrees, right? But then we learned the sum and difference identities, and we were like, oh, wait, if I do sine of 45 minus 30, now all of a sudden I know how to do sine of 15, right? Well, there are other options as well. What if, how about if you have an angle of 22.5 degrees? That's half of 45, right? So this is 45 over 2. So you know what? I can use that half angle to also evaluate sine of 22.5. Like, did you ever think that would have been possible? But you know what? Today it will be possible. So let's do that. So math is the coolest thing ever. So here is like sine and cosine and then the tangent equivalents of half angle identities. So this is sine of theta over 2. So for example, sine of 22.5. And then in here, you see how you have theta over 2 on the outside. Inside you have theta. This theta is your full angle of 45. Write that down somewhere. Okay. So find the exact value of sine of 22.5. Not a calculator in sight, right? So we're going to do this. Okay. First of all, take a look at that angle. 22.5 is in quadrant 1. That's going to come in handy, right? Because there's a plus minus situation here. Do you see this? Okay, so now sine of 22.5 is the same as sine of 45 over 2. So this is the same as plus or minus the square root of 1 minus cosine of how much? What's theta? 45 over 2. So now, what quadrant did we say 22.5 was in? 1. In that quadrant, is sine positive or negative? Positive, so I take the positive of this, okay? So this is going to be positive 1 minus, what's cosine of 45? 1 over root 2 over 2. Okay, you can't leave this like this, you have to simplify. The best way to do this is the following. Okay? You see the main fraction? We're going to multiply top and bottom by the common denominator of everything. So the common denominator of 1 and root 2 and 1 is root 2. So I multiply by root 2, multiply by root 2, distribute. Root 2 minus 1 all over 2 root 2. And that's it, we're done. Right? And this is one case where you have a root inside another root. It's root 2 over 2 or 1 over root 2. Okay? Okay. Questions? Okay, so far so good, right? Okay, take a look at this one. Oh my, sine squared x over 2, cosine squared x over 2. It's an equation we have to solve. Let's rewrite this. Let's rewrite this like this, because it's the same, right? And what can I do to both sides of this? Take a square root. So sine of x over 2 is equal to cosine of x over 2. Okay, that didn't get us anywhere. But you know what? We have trig identities for this. So what's sine of x over 2? It's plus or minus the square root of 1 minus cosine x all over 2 plus or minus the square root of 1 plus cosine x over 2. What can I do now? Square both sides. Okay, now, when we square both sides, right? You see how you had a plus or minus here? When you square it, does that matter? Because it all turns positive, right? So now what I have then is 1 minus cosine x over 2, 1 plus cosine x over 2. So the 2's cancel out, right? So I have 1 minus cosine x equal to 1 plus cosine x. Oh no, there's a solution. Hang on now. Okay, so what now? So let's take everything to the same side. What do we get? Well, yes. Negative 2 cosine x is equal to 0, right? Because the 1's go away. So cosine x is equal to 0. So what's x then? Pi over 2 and 3 pi over 2. Right? Fabulous. Okay. Now, sometimes in higher level calculus, we have products of two trigonometric functions, like cosine 2x, but then sine of a different angle, 5x. Sometimes to simplify them, we need what we call product to sum identities. Product to sum identities. And those are right here. So let's look at the first one. Sine of an angle times sine of a different angle is equal to half of blah, blah, blah minus cosine of blah, blah, blah. So it takes sine times sine and changes it to something minus something or something plus something. All right? Okay, so again, now do you see why there is no memorizing this, right? It's just too much and too unnecessary. Yep.
For sine times cosine times sine, why is it not the exact same thing?
But they're the same. There is no sine, cosine, and look, they're all different. So there is a.
Why is that?
Huh? Well, no, because you have sine times cosine, but you don't have a. But the angles are different. So if you had you know what I mean? So if you had one of these and one of these and they're added to each other, then they're different things. You see what I mean? Yeah. Okay, so rewrite this as a sum or difference. There's very little thinking in this one. Okay, so cosine times cosine, which one am I going to use? This one, right? Okay, so this is going to be 1/2 cosine 6x minus 3x plus cosine 6x plus 3x. So this is 1/2 in parentheses cosine 3x plus cosine 9x, and that's it. You're done. Okay? You cannot like divide the 3 and the 2, right? Remember, like they're outside. But you know what? Before we move on, what if you had this? Because this comes up all the time. What if you had signs of these? So what if you had this 1/2 sine 3x plus 6x, and then plus sine 3x minus 6x? What happens now? So this is 1/2 sine 9x plus sine negative 3x. Right? What do you think? Yeah, Logan. Exactly. This is not simplified. So this might give you like partial credit. Then you have to bring this out. So this will be 1/2 sine 9x minus sine 3x. No, you can't combine them. You can't do sine of 6x. And you know what else I see all the time, which is very sad because I hate taking points off for it. If like sometimes it'll be like 1/2 sine 4x sine, I don't know, 6x. And a student will say sine 2x sine 3x because they'll divide. Oh my God, yes, it is kind of funny and so wrong. It's funny and sad all at the same time. Don't do that. Huh? I mean, no, but like eventually like somebody will like distribute the half here. And then those are things where those are like the only times where I'm like, I flip back to see whose test that is. Because normally I'm going so fast, I don't even look at names. But then I'm like, who did this? You know, and don't ever be that person. Don't ever. I might.
That's fair, honestly.
Right? I mean, because, like, dude, come on. Like, we came all this way. Right. Exactly. And we came all this way to just do that. Like, it's so rookie. We're not going to do that. Okay. Okay. Let's do more. So here, we went product to sum. But there's a lot. But you can also go sum to product. Right? Sum to product. Yeah. Sometimes, but then there's also equations with them.
Okay.
Yeah, some of them, yeah, because we're just getting used to, like, we're just familiarizing ourselves. But then there is also equations. Yeah. No, none of the 5.5 ones. Okay. Yes, I said all of this before. Yep. Okay. So let's do this one. Find the exact value of cosine this plus cosine something else. So we're going to use which one? This one. Okay? So look, cosine 255, cosine 195, I don't know what these are, but let's see what this comes out to. So this is going to be 2 times cosine, you add them, divide by 2, and then cosine, you subtract them, divide by 2. Yeah? So 2 cosine, right? So when we add these, it's 200, 350, right? 450. And then when you divide by 2, it's 2 cosine 225. Right? I know. And then cosine, this is what? 60 over 2? 30. Oh, wow. Look at that. Yeah. 225, that's a special angle, right? In quadrant 3, quadrant 3, what's the cosine there? Negative 1 over root 2. Cosine of 30 is how much? Cosine of 30. Root 3 over 2. And then 1, 2 cancels with 1, 2. And yeah, because they're all being multiplied, right? Associative property. And then so this is negative root 3 over root 2. Okay, and can we just pause to appreciate this? Because look at this and look at this, right? Like, but look at this, look at the problem. Would you ever have thought that you could have done that without a calculator and got such a cute little answer? You know what? If you're not gonna appreciate this, just like
I don't understand.
just okay. It's okay. Huh? No, because we're not rationalizing the denominator anymore. No. No. In the book, it'll be negative root 6 over 2 because they rationalize, but we don't need to rationalize. Yeah. No, they don't. So it'll be this, but also meaningless. Okay. Yeah. Hmm?